Welcome folks to video number 50, our 50th video. Dang. This video is part of a series where we've been working on using radar imagery, and our ultimate goal is to classify wetlands in the Middlebury, Vermont area. So the last few videos we processed the radar imagery, we geo-referenced it, then we filtered and averaged it. And now what we want to do is we want to start working towards combining this radar data with Landsat data and also with elevation data so that we have the most possible leverage on our classification. So why does it make sense to combine radar imagery with Landsat optical imagery? Well, obviously the optical imagery is really good at telling colors and also really good at identifying spectral absorption peaks, for example, in the infrared or the near infrared. So there's a lot of compositional information in the Landsat data. However, the Landsat data can't see through leaves. If it sees green leaves, it pretty much looks like green leaves. The radar data, on the other hand, in particularly the L-band radar that we've been working with, is long enough wavelength that it's actually able to penetrate much of the canopy, and actually we're getting radar returns off of the floor of the forest in many cases. If the floor of that forest is very damp and wet, such as would be in a wetland, then we're going to get a particularly strong return off of those pixels. So we're going to combine the strong returns from wetlands in the radar imagery with maybe some unique coloration or infrared absorption in the Landsat imagery. And we can also combine that with elevation data. One thing we do know about wetlands is that they cannot occur on steep slopes. By definition, wetlands can only occur in really flat areas. So ultimately we're going to use a mask to actually mask out any areas that aren't flat. So our goal is to combine all three types of imagery in a single classification. And that's a little bit tricky, and there's a couple ways that we can combine this imagery. One possible workflow number one, is to actually just try to put all this imagery into a single multi-band raster. And so in particular that would involve combining the radar and the Landsat image into a single multi-band raster. And to do that, we actually need to resample these data, and I'll talk about that in a second. We would then apply an elevation mask and then apply a classification scheme to that multi-band image. The second workflow that we could try would be to actually perform a hue saturation value fusion of the radar and Landsat images. This is a type of pan sharpening, and this is going to be the topic of the next video. Once we had fused those two images, we would apply an elevation mask, and then we would classify the wetlands using the fused image. So in this video, we're going to start out on workflow number one. I'm going to show you how to sync the radar and Landsat images into a single multi-band raster. And before I show you how to do that in ENVI, I'll just give you a brief explanation of what resampling is. So here's an example of a gridded raster data set where the values of the data are shown as heights in these columns. Okay? Each column also represents one spatial pixel. So this is a pretty high resolution data set. These might be our 12.5 meter radar pixels. But remember that the Landsat data has 30 meter pixels. So in order to directly combine these two images and use them for classification, we'll need to resample these 12.5 meter pixels down to 30 meter pixels. And that's going to involve typically averaging or weighted averaging several pixels from the radar image and assigning that value to a single empty 30 meter pixel that's laid out on the same grid as the Landsat image. So that covers why resampling is necessary. Now let's head to ENVI, and I'm going to show you how to use the layer stacking tool to do this resampling. So back to the ENVI project. I've got my Landsat image, and then I've got the two filtered radar images that we just created in the last video. Just to verify this, I'm going to right click on that filtered image, go View Metadata, Map Info, and the pixel size is 12.5 by 12.5 meters. Let's do the same on the Landsat image. Go to Map Info, and we can see the pixel size here is 30 meters. So as I said, we're going to need to resample these radar images to a 30-meter pixel size. So an easy way to do that in ENVI is to use layer stacking. That's under Raster Management, Layer Stacking. And we're basically going to wrap these into a single file, multi-band raster, and in the process of doing that, the radar is going to get resampled. So I'll import, I guess I'm going to choose to go with my gamma filter, and I'm going to combine that with my Landsat image. Hit OK. I'm going to reorder the files so that the gamma filtered radar comes after the first 7 Landsat bands. I'm going to leave the projection alone, and I'm going to specify that I want this new composite image to be resampled out at a 30-meter grid spacing. And I'm going to choose to do the resampling using a bilinear scheme that you learned about in the homework. I'll specify a file name, and I called the file radar_Landsat_30meter.tiff. I'm all set. Here we go. Okay, so that stacked multi-band raster has now been added to my project. Let's go have a look at it in the data manager. So we'll just check by right-clicking here, View Metadata, Map Info, and sure enough, this whole file now has a 30 by 30 meter pixel size. So it's ready to go, and we can do a classification using all 8 of these bands, including the raster band that's now embedded in the multi-band raster. So in conclusion, we talked about a couple different strategies to move towards fusing the radar and the Landsat images together for classification. One of those involved resampling into a multi-band raster, and we just did that using layer stacking in ENVI. In the next video, I'll show you how to do HSV pan sharpening in ENVI, which is the first step in the second workflow. Thanks for listening.